Welcome to lesson 1-6, and we're going to dive into finding intercepts from graphs, and this is video 1. Alright, so our learning targets up here are, we actually just have one. It says, I can determine the x and y intercepts of functions. And don't forget, we have our vocabulary that you can access here, or you can see here and then access in the glossary in the back of your textbook. So don't forget that you can utilize that. And today we're going to be talking specifically about x-intercept and y-intercept, and then we'll mention roots as well. So here it says the graphical concept of x and y intercepts is pretty simple. The x-intercepts are where the graph crosses the x-axis, and the y-intercepts are where the graph crosses the y-axis. And this visual over here for you is a great thing to have and reference in your book, because what it will remind you is that when you're looking for the x-intercept, you need y to be 0, and when you're looking for the y-intercept, you need x to be 0. Alright, let's do a couple examples down here. So example number 1, we have 3 different examples for example number 1. For the first one, we have a linear function, and we're just going to kind of estimate here. It looks like this is crossing maybe about at 3 1/3, and exactly where it is not as important as understanding that your x-intercept, you will always have your y value be 0. So here I'm going to say this is 3.3, we'll just say it's 3.3 repeating, comma, 0. So we'll put that here, and this crosses the x-axis at that point. So that's 3.3 repeating. If you put 3.3, that's fine, as long as you're kind of in that ballpark there, comma 0. And so our y value is 0. Now our y-intercept is where it crosses this y-axis here, and it looks like that's about at negative 1.1/3 or maybe a fourth. I'll just say 1.13 or 1.3 negative. Let's do it like this. Hold on, negative 1.3. And this is where x is equal to 0. So for our y-intercept, our x is 0. For our x-intercept, our y is 0. Let's do the quadratic here. So on the quadratic, it looks like it's crossing in 2 different spots. We've got one here and one here. So this first point looks like it's 3, 0. And our second one, it looks like it's negative 1, 0. So we'll put that here. So negative 1, 0, and 3, 0. And notice I'm putting these in as points and not just x equals a number, because they are actually points. It's where they actually cross. And then lastly, we have our y-intercept, which is down here at about negative 3. So we'll say 0, negative 3. Alright, now lastly, we have an exponential function here, and remember this equation y equals 2 and this dotted dashed line here is not actually part of the graph. This is what we call our asymptote. And you can see that our graph is approaching this asymptote, but it's never going to touch it, it's never going to cross it. So that means that this graph is never going to intersect this x-axis right here. So we can just say none. So there's no x-intercept. Now that's not always going to be the case for exponential. Sometimes it will cross the x-axis, but for this one it's none. And then you can look on the y-axis here and see that this graph crosses the y-axis whenever y is equal to 5 here and x is 0. So this will be 0, 5 for your y-intercept. And you can label it up here too if you'd like. So it's 0, 5. And then the last thing I want to mention about here is this right here. So how many can I expect to see? So if you're talking about a linear function, you're going to see it cross the x-axis once and the y-axis once. If you're talking about a quadratic, it could cross 0 times, 1 time, or 2 times. And then the y-intercept, you're only going to have 1. And then lastly, for exponential, it could either cross 0 times or 1 time, and then the y-intercept will only cross once. Alright, so go ahead and try those U tries, and I will see you in the next video.